Hi, welcome to Live Life Ravishingly. Today we'll continue our AI journey, and I have brought a new episode on AI with Shivaram. Welcome, Shivaram, to my show.
Hello, Ravi. Glad to be here.
Thank you. Today we are going to learn about deep learning. What exactly is deep learning and how we can use deep learning in our current situation. Yeah. So, Shivaram, tell me, is deep learning also AI?
Glad you asked that question.
Thank you.
Today there are a lot of jargons, okay, and people have come out with so many different things. Every company comes out with new things and so on. But deep learning is a very fundamental concept which is there in AI. It is part of AI. Okay. So as I mentioned in one of the previous videos, artificial intelligence is a way of making anything which is artificial, which is not living,
Right.
to behave in an intelligent way and to solve problems in an intelligent way and so on.
Correct.
Right. That can be done in two main ways. One is humans putting their intelligence and codifying it and giving it to the writing algorithms and giving it to the AI, and the other is to make the algorithm learn by itself by us providing data.
Got it.
Okay, we provide data and the algorithm learns on itself, right? So when we provide data and the algorithm learns on itself, that part of AI is called machine learning. Okay. And when machine learning is taken to the next level, you get deep learning.
Okay.
So even in deep learning, we provide data and we expect the algorithm to learn on itself. Okay. So the algorithm or the model, we call it either an algorithm or a model, learns on itself when the data is provided to it. Now what is the difference between machine learning and deep learning? That is the question we get. Right. So machine learning is a model which is simple. Simple in the sense it has less number of variables. So let me give you an intuitive understanding of how AI works. Okay. So when you are training an AI model, you need to assume that you have in front of you a huge board, like the DJs have this board, right? And they vary the knobs and get the right music, frequency, all those things. Imagine a board like that in front of you, okay? And you are tuning it such that some input what you are getting and some output what you are expecting the model to give are as expected from the model. Like for example, if you are giving an image of a cat, you have to see the cat as the output.
Correct.
Right? Until then you tune it. Okay, until you, like, that's not the way it actually happens. It happens in a slightly different way. I'm just simplifying it. So you tune the knobs so that you get cat. And if you show dog, it should show dog as the output. If it is showing cat, you change it. If it shows dog, you don't change it much, or you change it in a way which makes it more dog.
Got it.
Okay. And so on. So this is a typical way algorithm is built. In machine learning, there are very few variables, as I said, maybe 5, 10, 15, 100 max, right? Deep learning involves a lot more parameters. Imagine those knobs. Imagine millions of knobs. Thousands, millions, sometimes billions.
Got it.
Right? So these knobs, we don't tune it ourselves. Okay. While DJ tunes the knobs themselves, here in this case, the knobs are auto-tuned.
Wow. Okay.
So there is an algorithm which auto-tunes the entire set. Okay. And that algorithm is controlled by the amount of error which is happening, what knobs are creating what problem. All those things are analyzed. There is something called as back propagation algorithm. So you take the error from the end and you propagate it backwards. And you fine tune it. Okay. So that is what is auto tuning this, and that's where the learning happens. So learning is the auto tuning of this knobs.
Got it.
Okay. Now knobs can also be called as weights. Weights can also be called as numbers. Okay. These are numbers which are changing. So we call them weights.
I see.
Okay. So for this video, let's call them knobs itself.
Okay.
The fine tuning of the knobs are set auto set by the algorithm. So another algorithm which is running and checking the mistakes, and if there is a mistake, it corrects it. Okay. Now deep learning is inspired by human brain. In human brain, like for example, if we see the vision system, what we are seeing, right? Our vision system has one layer of neurons, and that information goes to the next layer, and that information goes to the next layer. What are layers? There is one layer of neurons, means imagine there are 50 neurons here, okay, on the surface of my hand, and then there are another 50 neurons here, okay. The information from here goes to this layer, okay. Then there is another 50 neurons, 50, 100, it depends, right? It can have different number of neurons in every layer. The information is flowing layer after layer.
Okay.
So what it is doing is it is trying to solve a bigger problem into smaller chunks. It is dividing the problem into smaller chunks automatically and solving it.
Okay.
And over time, it is solving tougher and tougher problems. So what people saw was when you put stacked multiple layers of neurons, you could solve tougher and tougher problems.
Got it.
Instead of just having few layers. So when I was doing my master's, I was using AI to model something, neural networks to model something. And I went to my professor and I mentioned, okay, I did this, I can solve any problem, I can keep stacking this. He said, no, it is not possible, because he spoke about a problem called vanishing gradient problem. So what this problem says is, when you're auto-tuning this box, when you're varying the knobs and auto-tuning this box, machine learning box, the information, when it flows backwards, the first set of knobs which are closer to the output, they are tuned properly. And as you propagate the error backwards, you don't know which one caused the problem, which knob is causing the problem, you don't know.
Okay.
So the problem is, like, the amount of error and amount of correction depends on something called as gradient. Gradient is the slope of the error versus the parameter, right? Now that slope becomes zero as you move backwards. And then you don't know which knob you have to correct. In the first few layers, there are knobs, you don't know which one to correct.
Correct. Okay.
So that was creating a problem as to how many such layers you can put. If you put more layers, you cannot tune itself.
Correct.
Then like, people figured out clever ways of doing it. They modified the activation function and various other things they did. So they could configure the auto-tune however large the size of the network is.
Got it.
Once they solved that, the deep learning actually came into being.
Okay.
One such successful model, which is the pioneer model, came out in 2012. It's called AlexNet.
Okay.
Okay. You must have heard of Jeffrey Hilton.
Yeah.
So he also got Nobel Prize, right? So it is mainly because of the achievements which he did in deep learning and so on. So when you stack the neurons one next to each other, they can solve any kind of different problem.
Got it.
Okay. Now I'll tell you one main distinction between machine learning and deep learning. One is obviously the number of parameters.
Right.
The second is, because the number of parameters is huge and it can auto-tune anything, we don't even have to do feature engineering.
Okay.
So what is feature engineering? I told you, right? If you have a tough problem, you need to tell AI what to use, what not to use. You have to hand code and make the features. Right? Think about this, and so on. Now deep learning is going to do it itself, because it's so big, it is so smart, that it can solve the problem itself and figure out which are the features which are needed, which are the features is not needed. But the only thing is, it requires huge amount of data.
Got it. Yeah. Data is the key. Yeah.
Data is the key. And larger the amount of data and larger the size of the model, tougher problem it solves and better it is. That's what we saw the trend. That was a trend, and that is when people started using these GPUs to train these models, and then, like, all the revolution started.
Got it. Okay, you said it can solve tougher problems, right? So can we solve any problem with the help of deep learning?
No. Okay. We cannot solve all kinds of problems in deep learning. Okay. Even like, I'm talking about deep learning before few years back. Currently, there are models which can work on different domains, but traditional deep learning, for text, you have one type of models, one architecture of models which work. For images, you have a different architecture of models which work. For audio, you have different type of models it works, and so on, right? So deep learning is model specific first. For simpler problems, we should not use deep learning. Okay. Because it can create more problem than it solves. It doesn't solve all the problems. So what ends up happening is when you have a simple algorithm, right, you can understand how it works. If there are any mistakes, you can correct it.
Got it.
Okay. Whereas when you build a deep learning model, you don't know what's going on in the model. It's so big, you cannot understand how each and every parameter works.
Got it.
So you don't know how it is solving. So for a given problem, if it is a simple problem, go with machine learning first. Before machine learning, you first figure out, is it an AI problem or not? Can you program it or not? If you can program and solve it, then program and solve it.
Right.
Okay. Then you go into machine learning, then you go into deep learning, and then others, like and then language models and so on.
Got it.
Today, large language models have kind of simplified a lot of tasks which were earlier going into deep learning. Okay, by the way, large language model is also deep learning, so it's an extension of deep learning.
Got it.
So basically, it has solved a lot of things. That said, don't use deep learning as your first solution.
Got it.
Okay, and there are problems where deep learning cannot work. Even today, there are tough problems cannot work. That is going to change over time.
Got it.
As we do innovations and stuff.
Got it. Great. Lot of stuff I'm learning as well. Now tell me, what are trade-offs in this deep learning, like advantages and disadvantages of deep learning?
Okay, when you are using deep learning to solve a problem, you may think it is working well, because you normally when you are training AI model, you have trained data and test data. You would have tested it on test data and said, okay, this is working.
Yeah.
But it is deep learning models are highly prone to different kinds of biases.
Okay.
If the data is biased, the output will also be biased.
Oh, okay.
That exists in all AI models, but with deep learning, you cannot figure out how much is the bias until you start using it. Like for example, testing a machine learning model is easy. You can give inputs and outputs, and you can see how it is behaving. With deep learning model, the amount of inputs and outputs you have to give to check if it is working well is huge. So you may not be able to robustly test the model to figure out whether the bias is there or not. Okay. You need to have a huge data set to test it.
Got it.
First. Second is, they are heavy. So they need GPUs to run.
Got it.
During inference as well. Inference means when you train the model, after you train it, you are just using it. You are not learning anything.
Got it.
You are using the learned thing. See, people have this misconception that AI keeps learning all the time. No.
Yeah.
AI learns only during its training. When it is in the inference mode, it is not learning.
Got it.
Okay. We are just using the model. Okay. When you are using the model inference, when you are doing the inference, even then there you need large compute. If it's a machine learning model, you can run it on each thread on your CPU. Here, if it is deep learning, you need GPUs. Okay. So it's costly to run. It's costly to maintain. It is heavier. It needs huge amount of data. So there are a lot of trade-offs.
Got it.
So when you are using a deep learning model, you should be cautious. Okay. Unless it is required, don't use it.
Got it. Okay. In between, you spoke about LLMs, right? Are they same as deep learning?
Yes. So I'll just tell you how they are same.
Okay.
So basically, large language models are particular types of deep learning models, which are specifically useful for tackling language, like question answers, chatbots and all those things. Large language models have the power to understand language and generate language. They are a kind of a generative model.
Okay.
And in today's world, most of them use transformer based architecture to do it. We can have a separate video on transformers. So what transformers do is they have various mechanisms to take a large amount of text and understand the context and give different attention to different parts of the context window. And based on that learning, they can predict what should be told next.
Got it.
Okay. So we can have a separate video completely on that and how LLMs are trained and so on.
Sure.
So these LLMs are quite powerful, and it shows how deep learning models are evolving.
Got it. Okay, so I'm learning AI now. Anyone is learning AI. As part of AI learning, or as part of AI course, or as part of AI studies, should I learn deep learning?
Yes, yes, you should learn.
Okay.
So I prefer people learn things. They learn deep learning, they learn machine learning, and then they learn large language models if they have time, instead of just jumping into large language models and the latest generative models and so on, because that gives you more context.
Okay.
Just that gives you a feeling of what works, what will not work. If something doesn't work, why it may not be working, how we can tweak to make it work, and so on. So to do that, you need to understand deep learning. So there are a lot of courses out there. One of the famous courses, fast.ai. There's a course on deep learning, which is for not just programmers,
Okay.
for newcomers as well, but you have to learn programming. It is pretty good course. I think people should take that and learn it.
The information that we are getting, I am getting, my viewers are getting, is amazing. And we'll continue our journey with Shivaram on AI. For now, thanks Shivaram for joining my show.
Thank you, Ravish.
Stay tuned.